My name is Asa, and in this project I investigated projectile motion with and without air resistance using GlowScript. The goal of this lab was to model a real physical system and compare it to a physics model. The purpose of this investigation was to understand how air resistance affects projectile motion. We often just simplify problems by ignoring air resistance, but in real life it plays a minor role, and I wanted to see how big the difference actually was. So the system I modeled is a ball being launched into the air. I created two versions of the same motion, one with air resistance and one without. And both start with the exact same initial conditions, so any differences come purely from the physics model. This model is based on Newton's second law, which states that force equals mass times acceleration. I included two main forces, gravity and air resistance, which is also called drag. Gravity acts downward at all times. Drag force acts in the opposite direction of motion, meaning it always slows the object down. An important detail is that drag depends on the speed of the object, specifically proportional to velocity squared. In my simulation, both balls have the same mass and initial velocity. The only difference is that one experiences drag and the other does not. This allows for a direct comparison between ideal physics and then more realistic physics. And these are the results. And as you can see, here are the trajectories. The red path represents motion without air resistance, which forms a perfect parabola. The blue path includes air resistance. You can see that it does not go as high and does not travel as far. Looking at the height versus time graph, we can see another key difference. Without drag, the motion is symmetric. The object goes up and comes down in a mirror-like pattern. With drag, the symmetry is lost. The object slows down more quickly going up, and it falls differently when it goes down. This happens because drag removes mechanical energy from the system. Energy is not conserved in the same way because some energy is transferred to the air as heat and as turbulence, which, as a result, the projectile reaches a lower height and goes a shorter range. And then this concept is very important in real life. In sports, air resistance affects how balls move through the air. And then in engineering, it's critical for designing things like rockets, airplanes, and projectiles. And that's why ideal equations are useful, but they're not always accurate for real world predictions. There are several interesting extensions that could be added to this project. For example, you could model what happens if the drag increases, or what if the mass of the object changes, and you can see how does the launch angle affect the outcome. And these questions could be explored further using the exact same model that I created. So in conclusion, this project shows that air resistance has a significant effect on projectile motion. By using GlowScript, I was able to model both ideal and real motion and directly compare them. This demonstrates how physics models help us understand and predict real-world behavior.